Hello friends, welcome back to java9s.com. In this module, I'm going to discuss about the importance of overriding equals and hashcode methods provided by the object class. Please remember that overriding the equals and hashcode is extremely important when working with collections. I'll show you some examples to prove how collections can function in a wrong way without or with a bad implementation of these methods. Equals and hashcode also has direct relationship with the performance of the collection. So because collections effectively use these equals and hash code to determine a right object or to fetch them as fast as possible. Let us take a short look at the purpose of each method. Equals method is there to help in checking if two objects are equal or not. I mean, with respect to their content. But the implementation that is present in the object class only checks if two references refer to the same object or not. This is the default implementation that every instance obtains from the object superclass if we do not override the equals method by ourselves. Then coming to the hash code, it is a method which returns an integer. Objects hash code method returns the memory location converted into an integer. So the importance behind having a hash code is that it helps to identify an object in the heap of other objects. So this is helpful in maintaining the elements in collection so that collections can easily look for an object as fast as possible. I will elaborate more on how collections use hash code. Now first let us focus on the equals method. Consider that I have a student class which takes the student's registration number. This registration number is unique to each student. Now that I am creating two instances of the student and passing the same registration number, we show that these two instances represent the same student but are just two different objects. The main motto of equals method is to confirm that both objects are equal with respect to data. That means they are representing a single entity there. But the equals provided by the object class returns false when we apply these two instances. Okay, reason is that the objects implementation only looks into the values that these references hold, that is s and s2, and then compares them, and if they are same it is just going to return true. But it is not going to return true because s is referring to one instance. That means s is having a memory location of the first object and s2 is having the memory location of the second object. So both have different values and the equals method is going to return as a false value. That means actually internally objects equal method is just using an equals operator but not really looking at the internal data that we have, our registration number. Obviously object class will not have any idea about its subclasses, right? So when we create instances there's no point of knowing what kind of data we're going to create. So let us take a look at how this impacts performance of a collection. What are the problems that we face when we use this kind of object into a collection like map. Now I'm going to create that student object, I mean a class. So I'm going to create registration number. I will use string. Then I'm going to use the public constructor to get the registration number. And I'm setting that to the internal registration number. Okay, I will also generate the getter and setter methods for this so that I can set a different value or get this registration number outside the instance. Okay, so now the student is created. I will create an execution class so that I can write some statements to check. So we'll have a main method here. I'm creating the student class, student instance, new student, with just 234. Okay, registration number. Then I have this student s2 is equal to new student, and again it's the same string. Okay, so if I go ahead and look what equals object tells us about these two objects, you can see that it is just going to say they are not equal, so it's just false. Okay, the reason behind is that it is invoking the equals method that is provided by the objects class. Now we'll see how this impacts the functioning of a collection. I'm just going to create a map. Okay, map with a student as a key, and say report card as another class which holds some marks. Okay, so map is a key value pair, right? So I'm going to use student as a key here and report card as a value there. So that map only allows unique elements in the key area. Okay, I'm just going to create a report card. Okay, what I'm going to do, I'm just going to have a private int math score. Okay, just to show some score in the mathematics. I'm going to generate some getter and setter methods. Okay, now just to facilitate a little bit more functionality, I'm just going to have this report card constructor which sets some random number for the math score. Okay, I'm just going to say math dot random. I'm just going to say okay within 100, and then just to ensure that he does not get 0 there, 1. Okay, so this is something like that. Okay, so we have this report card now, and we need to import the map. So I'm just getting it. Yeah, so what I'm going to do is that I'm going to add student with a new report card. Okay, so students report dot put, I'm going to say yes, and I'm saying new report card. Okay, so this is a new report card, and for the S2 also we have new report card. Okay, then I'm going to put new report card for the S2 as well. This report card is representing there should be only one single report card, right? These two objects represent one single student. So right now this map allows both the students, which is wrong because the equals method says it is two different objects, but in fact there it is representing one single student there. Okay, so I'm just going to get some size here just to see how many objects are there inside, so how many key value pairs are present. Okay, we'll just run it. Okay, it is saying 2 are added. Now I'm going to implement an equals method here. So boolean equals object. Okay, and we need to, first rule is that we need to check if it is not equal to null. So whatever we are getting is not equal to null, and then we should also ensure that the object is instance of this type, because we don't want to compare some other types or accept some other type and validate to their input. Okay, so I'm just checking if the instance passed to this equals method is actually an instance of a student or not. Then what I'm going to do, I'm just going to get the unique value. Okay, rich number of the other student. So first thing is that we need to have a cast there, because whatever we have got is in this thing, so an object type. So then I'm going to get registration number. Okay, that should be fine. Now if reg number is not equal to null, so I'm just ensuring that it is not null, and reg number should be equal. So string already has an equals method overridden in it, so we can directly use string to compare there. So I'm just getting this dot get registration number of this object. If it is so true, then I'm just returning true here. If any of these statements does not pass through, then I'm going to return false. Okay, so this is a simple implementation of the equals method. I'm also going to write the hash code here so that it returns some unique number for each instance. So hash code. So what I'm going to do, I'm just going to get the registration number and just get the hash code of that string and return that, because each and every registration number is going to be different. So I'm just going to get the hash code of this string and returning it. Okay, so if I go ahead and check if the map still allows both the instances or not, you can see that it is not allowing both of them, because we have already given the implementation of equals method to validate if both the objects are same or not, and map in fact uses these methods to validate if both of them are equal or not. So I'm just going to show you if they are getting invoked or not. Okay, so just a simple statement to print out map. Okay, so you can be sure that map is actually using both of these. You can see that these statements are getting invoked multiple times. There could be on different objects. Okay, because there are two instances, obviously each and every time it compares both of them, so and ensures that okay, both of them are equal and only one is allowed, so the other one is getting rejected. So this is how equals and hash code really help in terms of helping collections to avoid any duplicates coming into the data structure, and they also actually help to retrieve the objects as soon as possible. So coming to the hash code, why do we need this hash code is that collections uses very specific strategy, kind of a strategy to reach out to objects as soon as possible to fetch them. So if you take an example out here, think of hash code. We have a kind of 10 objects with different numbers. Okay, we have different buckets there, and then we are numbering it 1 to 5, 5 to 10, or 6 to 10, then 11 to 15. Now that think that we have different objects out here with some numbers, then I have 7, 9, 11, 13 and 14. So if I say okay, collection, please store these objects into your data structure, then collection can actually put them into individual buckets. So 1 goes into this bucket, 6 goes into this bucket, 7 goes into this bucket, 9 goes into this bucket, 11 goes into this, 14 and 13 goes into these buckets. Okay, so when I ask for an object of 13, immediately the collection understands that, okay, I do not have to check these two buckets. I'm sure that the object is going to be in this bucket. So how many objects are present in total, or just three objects that are present here? So it is easy to pick out object from three objects in this bucket rather than looking out for a lot of objects in one single bucket. Hash code, in fact, having a hash code really helps in terms of easily reaching out to objects and fetching them as fast as possible.